Hi, everyone, and welcome to today's Germination Retail Roundtable webinar. We're exploring the world of oilseeds today. We'll be addressing new technologies and varieties, some exciting new research in the realm of oilseeds, and disease issues that are on the radar for those who deal with oilseeds. My name is Mark Zinkowitz, and I serve as editor for Germination, and today I'm happy to be your host. Before we begin, I'd like to thank our sponsors, 2020 Seed Labs, Canterra Seeds, and SeCan for their support. We'll be doing some live tweeting during the proceedings. I encourage you to engage with us on Twitter by following the hashtag #SeedRetail as we go along. During the presentation, you'll likely have some questions for our speakers. Please type these in the chat box at any time during the webinar, and we'll address them during the Q&A sessions we'll hold after each speaker finishes their presentation. Also, this webinar is being recorded and will be made available at germination.ca very soon. I'd like to begin with the first of 4 presentations today. Todd Hyra is Business Manager for Western Canada for SeCan. His love of agriculture started in childhood, being raised on a mixed grain and beef farm in Grandview, Manitoba. He continued his journey in agriculture when he began his career in 1990 in the seed industry, first at Proven Seed and then at SeCan. He's also president of the Canadian Seed Trade Association. Todd will begin by discussing some new technologies being introduced at SeCan in the world of oilseeds. Take it away, Todd.
Thanks, Mark. I'll rely on you to advance my slides for me, if that's all right.
Will do.
Excellent. So over the next 10 minutes or so, I'm going to touch on 5 new flax varieties and 4 new soybeans that will be available from SeCan, from 2018, looking forward as far as 2022, so a long way out, but there's some exciting stuff on the horizon. Next slide, please, Mark. So the 5 varieties I'll cover off come from 2 breeding programs, the University of Saskatchewan at the Crop Development Center, as well as Agriculture Canada breeding program in Morden. So these offer each some unique changes in terms of improvements within flax crop to help hopefully encourage some greater uptake in a broader area. So the first variety, next slide please. First variety is CDC Plava, and it was introduced for the first year in 2018 as a certified seed. It's a brown seeded variety. When you look at the yield, it's kind of in range of what you would expect for many of the new varieties, so about 5 to 6% higher than CDC Bethune. The real important part of this variety is 2 days earlier than CDC Bethune. And at the end of the flax varieties, I'm going to show you a look at, put them all on one page so you can see how they all compare. But it's taken a long time to break this very tight relationship between maturity and yield. And so have something that is actually higher yielding and earlier maturity makes a big difference. And this is the first one of those varieties. So CDC Plava fits very well in the northern seeded areas. And 2 days when it comes to fall harvest can be stretched into a week or 10 days very quickly. And so it's a variety that we feel will carve out a great fit as a mainstream product, not just in short season areas, but for individuals that want to not be battling flax harvest later into the season. So we label this one as having breakthrough combination of yield and maturity. Next slide, please. Just a quick look at CDC Plava in the field. Its height would be right in the range of CDC Bethune, stronger straw than CDC Sorrel, maybe not quite as strong as CDC Bethune. Next slide. And as mentioned, when you look at the variety's performance in the northern flax co-op trials, this is where it really shone, where you can see that maturity of most products in this earlier flax maturity range all having a little bit of a yield hit. But when you get to CDC Plava, actually has a yield bump and still maintains that earliness, plus all of the other characteristics that make it a good oilseed flax for Western Canada. Next slide. The next variety I'm going to talk about is CDC Buryu. It's new for 2019, also out of the University of Saskatchewan, the Crop Development Center, bred by Dr. Helen Booker. Its overall average yield would be 106% of Bethune, but this one gets its yield bump when you move it into the longer season areas. So when we saw this one coming through the cooperative trials, it actually had an 8% yield bump in the black and brown soil zones, and so offers a nice yield advantage over products like CDC Bethune that have been the staple for us for such a long, long time. Straw strength is in the same range. Height and maturity also similar to Bethune, but it's really about the yield in the longer season growing areas. Next slide. And here we have Dr. Helen Booker, the breeder for CDC Buryu, and this will be available for the first time the spring of 2019. Next slide. AAC Prairie Sunshine will be one of the last products coming, or nearing the last of the products coming out of the flax breeding program at Agriculture Canada in Morden. So this is Dr. Scott Duguid's program. Yield also in that 5 to 6% range of CDC Bethune. What interests us in this product is its strong straw. So made for high production conditions, has excellent lodging resistance, stronger straw than CDC Bethune. The watch out on it is that it is 3 days later than CDC Bethune, but does offer this very strong straw and a nice yield bump for high production areas. So it'll be brand new for 2019 as well, and available for the first time this coming season. Next slide. AAC Bright, also new for 2019. This will be our first yellow-seeded variety. And when I mean yellow-seeded, it is a bright yellow, almost like a sesame seed. And that's where we see a potential fit for this product in the food and condiment market, where you're using whole seed, either whole seed for bakery products as toppings or incorporated into bakery products, or ground up and incorporated to get the benefit of the oil in a whole grain product without turning the product a darker brown. So nice bright yellow seed, very strong straw, a little bit earlier than Bethune, and yield not far off of Bethune. So considering yellow-seeded varieties are relatively new, this one is right in the range of where it needs to be competitive from an agronomic perspective for producers. The one watch out with this variety, and as we've learned over the last year, is there is a trace level of brown seed in the variety, which would mean it would need to be color sorted through the production process as seed, but also as grain to ensure the highest quality product possible. So once again, AAC Bright, new for 2019, and reasonable availability. So a great fit for IP opportunities for flax. Next slide, please. The last variety that I'll talk about is a ways away, but warrants specific attention because of it checks many of the boxes that flax producers will be looking for. So this one is in breeder seed production now. So we're about 3 years away from the commercial introduction of this variety, but it's a bit of a game changer for us in our flax portfolio. The yield is 112% of CDC Bethune, so we haven't seen that before. The other piece that's really interesting is large seed. So I'm not sure if you can really picture what 17% larger than CDC Bethune looks like, but it's actually larger than CDC sorrel. So sorrel is known for having large seed, so this one has great yield and large seed. So both of those characteristics will be a really great fit for flax producers. Straw strength, also stronger than Bethune. So a really great overall agronomic package. The watch out on this one is it's going to be late. It's 4 days later than CDC Bethune, so it's going to require some management in terms of plant populations and seeding early, treating it as a high-performance crop, and I think it will respond that way. And when you look at the strongest overall performance in the long season areas of the black soil zones, 116% of CDC Bethune. So that's a significant bump up and something to watch for as this product comes into the marketplace. And if you look at all these products together in one place, you get a snapshot of how they're performing. So some significant advancements in flax over the last while and really moving us forward. Next slide. Won't spend much time on this one, but this is sort of a view to the future. CBIS is working on a non-GMO glyphosate-tolerant flax, and they're planning to introduce this one in 2019 in the United States and followed with Canada shortly after that. So we've been keeping in touch with CBIS, and this will be one to keep an eye on as we look for the future. Next, please. Going to spend just a quick couple minutes going through our soybean portfolio. SeCan is very well known for our wheat and not maybe as well known for our soybeans, but we have a great portfolio of soybeans that work well across the quickly growing area for soybeans in Western Canada. So the first product I'm going to talk about is Foot, which was released this past year. So next slide, please. It is a 2,400, one more please, Mark. 2,400 heat units, has an overall solid disease package, and has a yield index of 104% of our checks. So a decent all-around performer in the main growing areas of southern Manitoba and maybe the sort of the longer areas of Saskatchewan. Could you advance 2, please, Mark? That's Foot. Next slide, please. Bork is a new Roundup Ready Extend variety, also 2,400 heat units, big yield potential. IDC grouping on this one is just a little below average, but it's got a decent Phytophthora tolerance package, as well as some Sclerotinia tolerance. So mainstream product for most of the longer season areas of Manitoba. Brand new for 2019. Next slide, please. Prince is probably out of the 4 products the one I'm most excited about, primarily because of its yield index combined with a very early maturity. So 23, 25 heat units, yield index of 110, reasonable IDC score, but Phytophthora, Sclerotinia, and soybean cyst nematode resistance. So all in all, great disease package and excellent yield. So this one will be brand new for 2019. And then the last variety is super early. It gives a little bit in terms of its yield index, only at 90% versus the last at 110, but it's very early, has a decent IDC score, and once again, an overall decent protection package in the Roundup Ready to Extend soybean package. So that's a quick snapshot of what we have coming over the next couple of years. So when you think about SeCan, think about the wheat, you know those products, but also think about soybeans grown, processed, and sold locally. That's all I have.
Thanks so much, Todd. We're going to do a very short Q&A session right now. If you have a question for Todd, please type it into the chat box. Todd, I have a question regarding GMO versus non-GMO flax. I've heard a lot about GMO or transgenic versus non-GMO or non-transgenic flax, which you mentioned earlier, of course. Can you explain what the controversy is about?
Well, it might take more than a couple minutes to get this one in, but in short, it's really not about product safety, it's about market acceptance. And there are parts of the world that do not accept GM crops. And so flax has traditionally been one of those crops that has been non-GM. And so if we think back to 2009, there was the detection of a genetically modified product, Triffid, that was removed from the marketplace. Triffid there was nothing about product safety to the consumer. It was really about market acceptance. And in that particular case, it was not accepted by the end use. So as we look towards new technologies for flax and making sure that we're on side with those markets, we want to choose technologies that would be considered non-genetically modified so that we have broader market acceptance for those products.
I have another question, Todd, regarding straw strength. When you mention straw strength for flax, that is referring to its lodging resistance and not its ease of harvest, correct?
Yes, great question, Mark. Absolutely correct. It refers to its straw strength with lodging resistance so that the plant can be harvested quickly, easily. It does also infer that there will be some ease of harvest, not necessarily the straw breaking down, but you want to make sure that the crop is not flat on the ground so that it can be picked up relatively quickly and moved through the combine quickly and not forcing large crop through the machine.
What are the research directions for future variety development? Can you give us a little bit of insight on that?
So when I included CDC Roland in the package, that was the one that I wanted to get out there. This shows the potential that is in the crop when you can start to put all of these pieces. So CDC Roland was specifically selected for its yield potential, not really looking at any of the other characteristics. When it actually came to registration, that was the pleasant surprise that the seed size and the straw strength was also there along with it. And so as the breeding programs look at new material, this is sort of, we see this as our new benchmark, sort of what CDC Bethune did to the marketplace 20 years ago. We're hoping that CDC Roland will do that.
Great. Thanks so much, Todd. I'd like to introduce our second speaker, who's going to switch gears a little bit and talk about some exciting academic research that's going on in oilseeds. Gavin Chen is Assistant Professor and Canada Research Chair in Plant Lipid Biotechnology at the University of Alberta. He's recognized for his contribution to biochemistry, molecular biology, and functional genomics of vegetative oil formation. He's also made substantial contributions in the development of biotechnological strategies for increasing seed oil content, producing special seed oils, and also enhancing the performance of oilseed crops under stress. Gavin, the floor is yours.
Thank you, Mark. Thank you. Good morning, everyone. So today I will talk about this Oilseed biotechnology. Mainly I'll focus on these applications and the challenges. I just follow up Kevin's talk. I think the flax stories and new categories are really interesting. Actually, I work some part of this flax. For example, we want to know how this flax can produce a lot of alpha-linolenic acid. And also, as this GM flax case, actually I'm teaching this plant bioproducts, and it's a very good example. I use it almost every year to bring this discussion to the classroom about GMO and the GMO. It's really a market acceptance, I think. Okay. So in my talk, I will cover three parts. First, I will give an introduction about vegetable oil, oilseed crop, and biotechnology in brief. And then I've focused on these applications, benefits, and rapid development of oilseed biotechnology. In this part, sometimes I use canola as an example because it's a major oilseed crop in Canada. And then in one slide, I will talk about challenges of oilseed biotechnology in brief. So actually, when we talk about vegetable oils, sometimes we also use another words like storage lipids or triacylglycerol. And sometimes we just use them as the same thing. Triacylglycerol means one glycerol backbone connected to three acyl chain or fatty acids. That's a major component of vegetable oils. Almost 95 or more percent of vegetable oils as triacylglycerol. So basically, all the vegetable oils are the same if we think it's as a triacylglycerol. But when we see why they are different, for example, flax oil rich of ALA, alpha-linolenic acid, and olive oil we know is kind of healthy, and canola oils canola oil rich of oleic acid 18-1, and so on. So basically, difference really are related to this fatty acid connected to this glycerol backbone. So because the fatty acid different, so we get different kind of vegetable oils. That's a major difference. And as shown in the figure at the right side, this is the data from USDA. It shows the increased production and demand of vegetable oils year by year. We can see these numbers steadily increase every year. And the number for 2015 and 2016 is 185 million metric tons. And according to this analysis, is this number is predicted to be double by 2030. So that means the production and also the demand, the same thing. Okay, we got a lot of vegetable oils every year, and this is how we use them. We use the majority of that, 78% in food or food industry for humans, and 7% here as animal in the animal feed area, and also quite a lot, like 15% of vegetable oils, we use them in these renewable chemicals or industries. There's a large market as well. So according to oilseed crops or oil crops, here I use oil crops for a reason. So basically, the top four oil crops are oil palm. Here is so the palm oil we not only get from seeds, actually we mainly get it from the kernel. It's not from seed, but it's the productivity or the yield of oil palm is so high, it's definitely dominate this market for this food industry, and it's a saturated fatty, it's easy to transport, and so on, some advantages there. And the number two is soybean. It's popular growing in U.S. and Brazil, and we know now is the economic war between China and the U.S., and so the soybean price up and low, and also it affect Canada as well because seems the price of soybean from Canada and from U.S. they are somehow linked. Okay, number three is canola. Canada is number one exporter of canola in the world. We produce a lot of canola seeds, and we export almost 90% of canola oil or canola seed or meal to the rest of the world. It's also the number one seed crop according to the revenue generated, also the planting areas. I think this year is the number one, really first time larger than wheat. So it means a lot to the farmers and the agriculture or industry chain related to this product. And the sunflower is number four as well. Of course, there are also other oilseed crops in the world. For example, flax. Kevin talked a lot about flax. It's really interesting, and Canada really produce a lot, and it's a really good oil, and we export it to Europe, to other countries as well. And others like peanut is popular in Asian countries and other countries. And also, in addition to that, there are also other oilseed crops. They are not really used for food, but they have industrial applications. Like, for example, palm oil is really good as a dry oil, and castor oil. We know castor bean contains this toxic protein. It's lethal. It can be used as a weapon. But this oil is called hydroxy fatty acid. Contains hydroxy fatty acid. It's really good in industry, and is almost think as number one important industry vegetable oil. But the major producer now is India because it's not allowed to grow it in large scale in Canada, in US, and some other countries. So the major oil seed in Canada is canola, soybeans, and sunflower and flax. I think canola is still number one. And the growing of soybean expands, as I understand, rapidly, especially Ontario, South Manitoba, and also expand to Saskatchewan and Alberta beta as well. I think because according to breeding, if we can make the mature time shorter and more tolerant to this hard weather conditions, Canada is really a big market there. So, okay, as shown in one slide, like we want to double the production of vegetable oils by 2030, but how can we do it? So basically, two ways we can think about. One is we can grow more oil-producing crops, but it will either take lands from forest or take land from other crops, even in the rotationary planting system. Or another way is, so if we can improve the vegetable oil production or the yield of oil seeds per unit area of land, that would be interesting because we can use the same area to produce more oil. So the question is, can we use biotechnology to do that, to enhance this vegetable oil production? I think the answer is yes. But before I talk this, let's select two terms. One is biotechnology. Biotechnology is not means the same as GMO, although sometimes confused. So anything, let's say, if we use science or engineering methods, so in the direct or indirect use of living organisms or part of produce a living organism in their natural modified forms, we call it biotechnology. It includes the traditional breeding, no GMO, all these GM methods, or genetic engineering. That means we can put a gene in or take a gene out from this organism. But really nowadays, sometimes we talk about Oilseed biotechnology. People think, yeah, you're talking about GMO. So yeah, I follow this trend. I use biotechnology sometimes related to GMO in this presentation. So okay, the application of Oilseed biotechnology is very popular in Canada. For example, these herbicide-tolerant crops for weed control. Although there are no GMO methods to do it, but majority of it is still GMO, and it's adopted so quickly and popular now. 95% of all canola in Canada are herbicide tolerant, and it's used in other crops as well, like corn, soybean, canola, cotton. Even in Europe, we know Europe do not like GMO, but still there are GM crops or GE crops growing there. They say number like in 2016, those like BT maize is about 20,000 of BT maize growing there. So it's not absolutely prohibited, banned. Okay. So the benefit of Oilseed biotechnology, actually, if we think about those some numbers, is huge. For example, it increased this farmers' income because of this GM canola. According to the statistics, between 1996 to 2013, the increased farm yield up to 12% per hectare. That means extra 8 million tons of production. Also, it reduced this herbicide usage because of this Roundup or herbicide-tolerant cultivars. And it's some numbers, for example. So while total canola acres in Canada grew by 236% between 1996 to 2013, but the use of herbicide declined by about 18%. That means overall like 15.8 million kilograms. That's a big number. Because of that, actually, it's better for our environment, because if we use a lot of herbicide in the field, it can be toxic to birds and animals and even the farmers themselves. So according to these statistics, that can reduce like 30% in 2013. And also, because we use this herbicide resistance crops in it, we don't need to do that tillage so frequently, and the soil can hold more carbon dioxide. At the same time, if we count this use of vehicles and other things into it, we actually reduce a lot of greenhouse emissions. That means in 2013, again, as this number, that is similar to remove 500,000 cars from kangaroos. So that's the advantage part. And also the development for Oilseed biotechnology nowadays is really rapid. For example, we know recently it's in the news in the last 2 years, this GM omega-3 canola, they can make canola oil contains EPA and DHA kind of similar to this fish oil, and is somehow in the market, and two big companies, BASF and Seed, they are working on that. And in my lab, I do some research about this. For example, we produce this punicic acid. It's a special conjugated fatty acid from this pomegranate seed. Once we put the gene into canola, it can produce 10%. It can be used for industrial purpose as well. And also the rapid development of genome editing. You can knock out a gene quickly. And now even this genome CRISPR edited camelina reaching omega-3 fatty acid, is allowed to grow in the United Kingdom now. Okay. But there are still challenges of this oilseed biotechnology. This is the last slide. The major thing is the consumer's acceptance. It's not really about safety, not. It's mainly the consumer's attitude about it. Even in the U.S., over 50% of the people say, okay, GM is not good, it's not safe, and so on. And also sometimes it's too expensive to be used by small companies, because if you think about the investment to generate a cultivar and then really sell the seeds to the market, it's really time and money consuming. And also the regulation, for example, genome editing. USDA announced in March this year that okay, it's no GMO, but EU just announced in this week or last week that no, it's GMO. So they're still debating about that. It's also affected the attitude of the companies and also consumers as well. So yeah, thank you. That's all my talk.
Well, thank you so much, Gavin. If you have questions for Gavin, please type them into the chat box now. We'll have another brief Q&A session. Gavin, can you explain what all the science ultimately means for retailers and growers?
I think for the retailers and growers, it's from two parts. One is about basic research. It's actually far away from these retailers and farmers, because for example, we know how ARA is synthesized, how we can improve it, either with GMO or no GMO methods. But really, that's quite far away from we get new cultivars, flax, and to the market. But from the applied side, for example, if there are different cultivars, and we can quickly use these sequencing methods to know why they are different, and then we can generate markers that can be directly used for this molecular breeding with no GMO methods, and can make this breeding time much shorter and more targeted. So I think it would benefit, but some parts is far away, some parts really close.
Gavin, can you offer us any perspective on the fight against herbicide resistance, for example, glyphosate resistance, and what the future holds there?
Yeah. So because the way the Roundup resistance basically is related, now the popular thing used is related to chemicals, right? And two chemicals, they can kill plants by blocking different enzymes. So for the GMO side, they introduce genes from either soil bacterium or a regular bacteria gene into it to generate resistance. And there are also other methods for non-GMO methods to do it. But yes, I think this is really a good question, because sometimes when the weight if we use a lot for Roundup, the weight will be more and more resistance, and it's the same as other pathogens like Blackleg to Canola and so on. So that's a new breeding part. Like we need to introduce new genes or modify the genes, or with the traditional breeding methods to generate new cultivars that can be stronger resistant to this Roundup, or can be stronger compared to this weed. Then we can use Roundup or modify the Roundup products for it.
Well, thank you so much, Gavin, for your insights. We're at the halfway point in our webinar today. Thanks so much for spending your lunch hour with us. Our third presentation today is from Tsai, who's the canola product manager at Canterra Seeds, who's going to talk about some developments in the area of canola and soybean. Shaan has worked in the industry for over 14 years, rounding out his understanding of various crop types and all aspects of the seed industry, including R&D, product development, and commercialization, as well as marketing. He has had a hand in the development and advancement of many successful seed products in both Canada and the United States. Shaan, you're up.
Thanks, Mark. Okay, so I'm going to be giving you guys an update on some of the new developments happening in canola These will be in the areas primarily of, or I guess for the purposes of today, areas of disease management, herbicide tolerance, and even further down the chain closer to the end-use market. Okay, so I can advance these slides myself, right, Mark? Yeah.
Can, yeah.
Okay. Yeah, okay. So on the Blackleg front, a new Blackleg labeling system was recently rolled out. Based on an industry initiative and seed developer participation, growers can now know what type of resistance genes for blackleg they have in their hybrids. In the past, most guys just had a standard field rating to go off of, which only provided an approximation of what type of resistance they can expect. Now, though, with these new blackleg labels, a grower can now know exactly what major genes they have, so they can make better hybrid selections. So just a quick explain of this slide here. On the left, to simplify things, they basically had the resistance gene, and they assigned an alphabet letter to each individual resistance gene. Hold on a sec. There, you can see that arrow there. So here's here's the lettering system here. Here's the resistance genes here. And then what this means in practical terms is that for the hybrid, the traditional field rating %Westar R, that remains, but these new major gene labels are after the hyphen here. And again, each letter represents an individual major gene. So the more letters you have, the more resistance genes you have in your hybrid. So you have this field rating here, which is also known as adult plant resistance or quantitative resistance, and then you have a listing of the actual individual major genes. So some may wonder, well, how does that help me? Particularly, if you don't know what strains or pathotypes you have in your field. So this was definitely a reasonable question up until a few months ago, at least. You wouldn't have had a good understanding of what pathotypes were in your field, but now you do. Just recently, this is I think earlier this spring, I believe, a new stubble test was rolled out, and it's now available to growers, which now allows them to take stubble samples from their field and submit it to their local seed lab, which I believe 2020 is also involved. So these stubble samples can be either taken in the fall or in the spring. In the spring, if there's any crop residue left, that is. Submit these to their lab, and then the lab will then generate a profile of these pathotypes in your fields. You then take this information and match it up with the blackleg label on your hybrid, and you now have a more precise defense against the disease, which should increase the yield potential of your crop. How does it increase the yield potential of your crop? Well, a recent study by Ag Canada showed that even low levels of infection of the disease can cause significant yield reductions, up to 20%. So what does this mean in practical terms? Well, a guy may grow, say, a 40 bushel an acre canola crop and be happy and satisfied with that, but little did they know they could have had a 48 bushel an acre canola crop only had he grown a variety with the more appropriate blackleg resistance. So moving on to clubroot. So by now, most people will have heard about this soil-borne disease. It causes gall formations on the roots and deprives the plants of nutrients. Causes significant yield reductions. Clubroot story, of course, it's well known, particularly in Alberta. I'm sure everyone's seen this map here. Really, the key point, though, is that, at least to the best of my knowledge, it's not a problem that's getting any smaller. The disease is never contracted. It's always either been flat or expanded. And then, in fact, now we're seeing it was recently detected in Manitoba in 2014, and you can see the different the maps here. So in 2014, and over the years since then, more and more has been detected. Most recently, last year, Saskatchewan, was kind of, it seemed like a bit of an anomaly in the sense that there was none detected, but in fact last fall it was found in a rather big way in the North Battleford area. So again, it's no longer just an Alberta problem. I think it's fair to say that it's now a Western Canadian problem. There are a number of management strategies that are promoted, such as the complete sanitization of equipment before moving from field to field. There's been some work on managing soil pH, such as liming fields with encouraging results. The other way, of course, though, is genetic resistance and how best to use genetics in a sustainable way to manage disease, such as by using clubroot-resistant varieties prophylactically. So, grow a clubroot-resistant variety before you get it. But the other one that I just want to touch on today in terms of an update is that, as seen here as part of the Alberta Clubroot Management Plan, one of the strategies is to rotate between different sources of resistance. So much like in the same way that guys are encouraged to use different modes of action in herbicides, they were also encouraged to rotate different sources of resistance when those become available. So in the past, we didn't really. This was difficult because there wasn't much genetic diversity in terms of clubroot resistance. But now with new pathotypes becoming available to the seed developers for testing, we're starting to learn more about the different sources of clubroot resistance based on how these different hybrids respond differently to these new pathotypes. So guys who are concerned about clubroot stewardship should take a close look at what the various seed brands have to offer in terms of clubroot resistance, and I think you'll see that there are differences now. Okay, switching gears to herbicide tolerance. It has been a while since we've seen the launch of a new herbicide-tolerant trait for canola in Western Canada. As all developers can attest, a lot of work and energy goes into bringing a new trait to market. Many may have heard that we're going to see a new glyphosate technologies hit the market soon. One in particular is TrueFlex, which should improve the yield possibilities for canola growers. Key features of this particular trait are that growers will now have a significantly wider window of application, so right up until they can spray Roundup right up until first flower, and we'll also have the option of using higher rates if need be. So I believe that number is 1.33 liters per acre for the season for the whole season, which can be done in a single shot or in a split application. Or I guess the 1.33 itself can't be done in a full single shot, but you can go at a higher rate. But again, 1.33 liters per acre for the season as a whole, and then they can decide how they want to allocate those portions. So again, this it all comes back to yield. This will of course help with harder to control weeds. But why do we control weeds? Well, it's to boost yield. So again, this technology should contribute to yield preservation in that regard. Final slide. So just wanted to update you is on the end-use market side of things. This one is more related to the end-use market, but it does directly impact growers. There appears to be increasing interest in Clearfield canola, driven primarily by demand in the more niche non-GMO markets. So, whatever view one may hold on this particular end-use market, the reality is that it can translate into additional premiums for growers. For the 2018-19 season, growers will now have more options in terms of what seed brands of Clearfield canola are available for a contract premium. Canterra seeds of CS2500CL and CS2200CL, which are being accepted by handlers and crushers. So this is, of course, going to give growers more choice by allowing them to tap into the competitive advantage of the various products from the different seed brands. So again, just encourage everyone to have a look at what the different seed companies have on offer, and again, more opportunities on the Clearfield front of things related to crop profitability. And that's all I had.
Well, thank you so much, Shaan. We'll do another very quick Q&A here before we get to our final presentation. Shaan, how do you see the new Blackleg rating system working? How well do you think it's working out?
Yeah, so it is a newer program. I think it is fair to say though that at a minimum you can expect that it's gonna work better than what we have now. Right now we're relying only on a general, or not right now, but recently before now. We were relying only on a general field rating, which was in many cases at odds with the Blackleg reality in the field. In other words, we were relying mostly on luck. This new system again should add more precision to the overall management of the disease, and I guess in the sense that we're going to be using more of a scalpel than a saw in terms of a tool to manage the disease that way.
Another question, Shaan, in terms of clubroot, how bad do you think it's getting in the future on the prairies?
Yeah, well, I hate to be the pessimist, but the problem, again, as you can see by those survey maps, the problem doesn't appear to be getting any better. Again, year over year, it's just constantly expanding, despite everyone's best effort at containing it and managing it. There are, fortunately, a lot of work is being done by a lot of researchers out there on developing new management strategies for the disease. All the seed developers are putting a lot of energy into developing new sources of clubroot resistance, and so it's becoming a bit of an arms race between the pathogen and the breeding companies on trying to outsmart these new pathotypes. But despite all that, the year-over-year surveys don't seem to indicate that the problem is getting any better. I think at best we can, with the efforts in breeding and agronomic research, we can slow it down. But I wouldn't be surprised if the clubroot reality that we see in central Alberta becomes the new Western Canadian reality. But again, that's just my opinion. But I'm a bit more pessimistic when it comes to clubroot.
Another question, Shaan. Rotations are classical practices to fight against resistance development. What are other practices that you encourage farmers to adopt?
Yeah, so particularly on the herbicide front, I think this goes back to the previous question as well. So yeah, absolutely, we promote crop rotations. That is a critical tool when it comes to disease or even herbicide tolerance. But another message or another practice that we're really encouraging growers to do is to also think about tank mixing. So I know guys, particularly in soybean country, they have this. There's this idea of rotating trait systems. So we use Roundup one year, Liberty Link the next year, which is great because that's one potential method at helping to delay herbicide resistance. But another method, and what the research has told us is that it's actually tank mixing is a more effective option at delaying herbicide resistance than rotating trait systems. And again, so I think guys should also, take a closer look at those types of strategies if they're concerned about herbicide resistance.
Thank you so much, Shaan. Last but not least, our final presentation today is from Kevin Zaychuk and Sarah Foster at 2020 Seed Labs, who will end our webinar with some discussion of disease and spore sampling in oilseeds. Kevin is Business Development Manager at 2020, and his major roles have included participating in the commercialization of DNA-based tests for detecting fusarium on cereal crops, the molecular test for detection of the pathogen responsible for clubroot of canola, and assisting with the development of an authorized International Seed Testing Association seed sampling program. Sarah works extensively with experienced seed analysts in North America. She's completed accreditation for the United Kingdom, the United States, and Canada. She's regularly invited to train and teach, as well as offer grading courses to authorized seed establishment personnel. Can you hear me all right, Kevin?
We can hear you. Can you hear us, Mark?
Yes, we can. Perfect. Take it away. The floor is yours. And if you need me to control the slides for you, just give the word.
Great. Thanks a lot, Mark, and hello, everybody. Sarah and I want to follow up on a few items. So some excellent material presented by Shaan. And I want to lead in. We want to talk a little bit about important diseases to keep your eye on, and also some new detection technology that we are looking at in the laboratory. So I got a couple of photos here. Clubroot, Blackleg, shameless plug for Canola Palooza. If you haven't attended Canola Palooza, you got to put it on your calendar for next year. So the Clubroot booth in Saskatoon was very well attended. Because of my plant pathology background, I'm always excited to see so many people interested in plant diseases. And just further on Shaan's presentation, I think it's so important for growers to stay aware of the pathogens, especially to be vigilant on your farm with proper cleaning of equipment, sanitation, and being aware of who is entering your land, especially if there's any construction. So, and attending these events gives you an opportunity to speak to the specialists. So Blackleg, the tent at Canola Palooza in Lacombe, that's our research manager, Kim Kenward, who volunteered there and talked about the pathovar testing that Shaan discussed in detail. I know this is Oilseeds, but I just had to put a slide here in for Fusarium head blight. We have to rotate our oilseeds with something. Cereals are susceptible to Fusarium head blight. Very important to stay aware of that as well. We can't talk about diseases without talking about the disease triangle. We're planting the host, so we've already got one point of the triangle. The other two are extremely important to be aware of. The environment, what are the conditions that are conducive to infection? And of course, you're not going to have a disease if you don't have the pathogen. So those are the 3 points that are important always to be aware of when we discuss pathogens. This is really interesting software that was developed, or a website that was developed by Alberta Agriculture last year. So this is the Alberta Fusarium Risk Map, and there's similar maps in Saskatchewan and Manitoba. If you're not aware of this, check it out. It's really good. So this is a snapshot in time of the province. You can see all these little gauges, and you can see some are pointing to the left and they're green, and others are in the middle and they're yellow, and other areas are red. So this is computer software modeling based on climatic conditions, rainfall, day and night temperatures, which are really important, which affect humidity and, of course, infection. So this is modeling just based on climate information. And this is another view of that website. And you can pick any location. You can also pick any time frame, so a single day. You can go backwards in time, so take a look at what the conditions might have been when your crop was flowering, because this is when cereals really are vulnerable, is during flowering. So take a look. You can look backwards in time and maybe look at whether or not you should have sprayed. So here's a quick snapshot. At the point on the far right, it was low fusarium risk, but you can see around the 22nd, 23rd of July, we had severe fusarium risk. So at Canola Palooza in Lacombe, there were some fairly big crowds all day long listening to this gentleman in the far background. That's Dr. Kelly Turkington, the pathologist at Agriculture and Agri-Food Canada in Lacombe. So he was talking about some really interesting projects on the go, including some new work by a team with Mike Harding and Shama Chatterton in Brooks and Lethbridge, looking at some microsensor technology to detect spores in the field as they land on the microsensors, with the ability, hopefully in the future, and they said they're at the very initial stages, but link that right to real-time reporting right on your smartphone or in your tractor, wherever you are. So sclerotinia, Kelly's got a project that he's launched this year, a 3-year project across the prairies. Watch for that. So This is a special spore trapping device. It's called a rotorod, and it's a volumetric sampler. So it's fairly detailed. It's really research only because it has a solar panel, a battery, a timer, a lot of electronics, and all of that just to support this tiny little device here, which is the rod. You can barely see it. It spins a certain amount of time so they can calculate exactly what the air volume was that it sampled. And then the spores stick to that rod. And now with new, better molecular technology or detection techniques, they can analyze the spore or the rod and see what spores have stuck to it. Previous to that, we'd have to look at it under a microscope, and it's time-consuming and not very exacting science. So this photograph illustrates the disease triangle I was speaking about. We can clearly see we've got a host planted. The environment, you look in the background, there is a rain event on its way. So that rain coupled with the host can provide some perfect conditions for disease. But we're not going to get the disease unless the pathogen is present, and that's always the difficult part, is when exactly is the pathogen present. And that's where this little device comes in handy that we've been looking at, and it's called the Spornado. I'm going to hand it over to Sarah, and she'll tell us a little bit about the Spornado.
Thank you, Kevin. Hello, everyone. So I'll give you a little bit of a history about the Spornado and how we came to find it. So back in the spring of 2017, we attended a Brazil-Canada agri-tech mission, and we were part of 12 Canadian companies that attended a series of events in Brazil. And this was part of the Canadian International Innovation Program that was designed for companies that were interested in bringing new and novel techniques and forming partnerships that might lead to some sort of technical commercialization for Brazil. But in actual fact, Kevin and I ended up meeting a company called Spore, who are out of Toronto, and they're specialists in air quality. And they're already using the Spornado in potatoes, and particularly in Ontario, and detecting late blight in potatoes. So we thought this had a lot of merit for being able to look at other crops across the prairies in things like soybeans, canola, and cereals. And of course, we've had this piece of equipment out in the field now for a couple of years, and we're generating some very, very interesting data. And if you know anything about 2020, we're vested in agricultural stewardship and always looking for ideas that are going to help our producers develop and produce very successful crops. So I think I've said enough there. We've got a lot of interest, and I'll just hand this back to Kevin.
Thanks, Sarah. And I'm sure your question is, how does this work? So this is a passive spore sampler as opposed to the rotorod, which is an active sampler. You can see there's not many moving parts to this. Looks like a weather vane, but the trick is in the special membrane that's attached to this cassette that's easy to insert and remove. And you simply remove the cassette and ship it to our lab in Nisku. So we have a mobile device or a mobile tracking system set up, so it's really handy to use on your mobile device. You can scan the barcode, enter some information about whether you're inserting it or removing it, and it also captures GPS location and some weather information about where you actually had the Spornado out in your field. We analyze it using DNA technology. And right now we're analyzing both Fusarium graminearum as well as Sclerotinia. We have an extremely quick turnaround time, 1 day. We had many cases this year where our clients dropped it off in the morning and had their results in the afternoon. So, and I guess to put all this together, high sensitivity. So extremely high sensitivity. We can detect down, I was going to say to a handful of spores, but that would be a lot. So we can detect just a few spores for both Fusarium and Sclerotinia. Here's an example of one of the sites. So this is in Lamont, east of Edmonton, and in this case I wanted to show you Fusarium since I'd showed you that monitor. And I should add too that I'd heard Alberta Agriculture working on a similar risk system, web-based risk system for sclerotinia. So that will be interesting to follow the development from that one as well. So this is the risk over the period of days. We just put the risk here onto this map so you could see it in relation to the pathogen that we detected. So here on July 7th through 8th, when the cassette was changed out, there was nothing detected. And then through the 9th to the 14th, trace levels detected. So that's just below our limit of detection. And then as the days progressed, and you can see the risk was actually climbing, then we were able to detect or get a very strong signal greater than our limit of detection. So that shows you how the conditions were conducive, and we were able to pick up Fusarium graminearum using that spornado. So lastly, I want to close out with the disease triangle again. It's so important to understand what the environment is or what the conditions are and if they're conducive to infection. And all the producers know this year, especially around our area, it's been really difficult. To say use a weather-based station that's even 5 miles from your farm because it could be wet in 2 miles down the road and dry in another place very close by. So using monitoring the environment and monitoring the presence of the pathogen can help you make an informed and better timed spray decision. And lastly, a couple of things to look for in soybeans. The soybean cyst nematode, a very small plant parasitic worm-like organism that can cause in low levels of infection in the field, you won't see any symptoms, but higher levels of infestation, the symptoms will be some early maturing and stunted plants. Phytophthora is another fungi to watch for. This can be found in cold, wet soils along with Pythium, so an important seedling disease of soybeans. And lastly, a plug for the Clubroot workshop. Just saw Sarah just pointed out on Twitter that Clint Yerke said today is the last day to register. If you have an opportunity to attend this next week, it'll be a fantastic opportunity to listen to international speakers on Clubroot. So with that, I'd like to say thank you very much.
Yes, thank you, everyone.
Have a good afternoon.
Thank you so much, guys. We'll just do another quick Q&A session before we finish for the day. If you have a question, just type it into the chat box. Kevin and Sarah, what do you see as the biggest oilseed disease threat on the prairies in the future, in your opinion?
Well, I think I would have to echo Shaan's comments on Clubroot. That's a big one, and we'll find out more at the Clubroot workshop. But I think that's where it's so important for the producers to be aware and I guess to see what's coming down the pipelines in the plant breeding side of things too. But Clubroot is an important one.
I'd agree with that.
And what's the advice you generally have for growers in regards to what their best defense is?
I think knowledge is the best defense, and it's always interesting speaking to the growers. I just spoke to a group of growers on Saturday, and they're very interested. The awareness is very high. Just the interest in knowing what's out in the field really helps them manage.
New technologies like Spornado, I imagine those will only get better as we move into the future. And do you see technologies like that playing a greater and greater role?
Absolutely. This is a big leap forward right now from previously trying to identify pathogens with a microscope or plating them out, and we still use that for a lot of pathogens. But this leap forward is I guess maybe bridging the gap to the next leap where we're going to have real-time sensors, like the project that Kelly Turkington and his colleagues have embarked on. So I think we'll watch for that in the future, but he said there's a lot of issues to overcome, but I'm sure they will.
Well, Thanks again, guys. That's all the time we have for today. I just want to thank everyone for participating in today's webinar, and I hope you found this information helpful. And again, thanks so much to our sponsors, 2020 Seed Labs, Canterra Seeds, and SeCan for their support. I'd also quickly like to thank our technical assistant, Teresa Kurdziewicz, who's been working behind the scenes to make this a successful event. Once again, this webinar was recorded and will be available on germination.ca in the near future. Thanks again, and we hope you have a terrific day. This is Mark Zinkowitz of Germination signing off.
Okay. Very, very good.